In this section, we're going to talk about continuous variables as opposed to those discrete variables we were discussing in the previous chapter. And when I want to think about my continuous variables, there's two distributions I can consider. The first one being a uniform distribution. We know from previous work that our uniform distribution takes on a rectangular shape. And we also know from a previous lecture that we were trying to make the connection between the area under a curve, which is equal to 1, and the associated probability of that area. So we defined way back when we looked at the empirical rule and we encountered a bell-shaped curve, that the area under that curve was representing 100%, or 1 if we want to take it into just a decimal form. We don't know how to find the area under the curve or calculate the area under the curve unless we've done some calculus work, but we do know how to find the area of a rectangle, which is our uniform distribution, which you see here. So as a reminder, remember that the area of a rectangle is equal to its base times its height. So if we are looking at this uniform density function here in yellow, and we define some random variable time to last between 0 and 60 minutes, so 0 over here on the left, so for the smallest number, all the way up to 60 minutes on the right to be the largest number, I can calculate the area of this yellow square by understanding how far, or what's the size, what's the length of my base. So my base has a dimension of 60 units. And then what we want to understand is, how will I know what the height of my density function is? So the height of my density function is always going to be 1 over the base of my function. So the height of my density function looks like 1 over 60 because the base of my function is 60. So these two numbers here, the height and the base, are called reciprocals of each other. So if the base is equal to 60, then the height has to be equal to 1 over the base, or 1 over 60. The reason for that is because if we plug this into our formula for finding area and we said, okay, my base is equal to 60, so my height's going to be 1 over 60, multiplying our fractions like this, I get an area equal to 1. So this area is equal to 1, which is what we want to start with. The area under my curves is always going to be equal to 1. And the way that I force my curve into that area equals 1 number is to have a height that is 1 over the amount of the base. So how do I use this now to calculate probability? Here is a question that we want to look at. It says the waiting time between subway departure schedule and arrival of a passenger are uniformly distributed between 2 and 8 minutes. There's two things in this first sentence that we need to understand and we need to highlight. First, we are explicitly told that we are looking at a uniform distribution. If you see anything that says uniform distribution and we're calculating probabilities, then you need to think, I'm going to draw a square. And then the second thing is, now we're given the constraints, or the amount of my uniform distribution. So we've got times ranging between 2 and 8 minutes. So to draw this density curve, which is going to be a rectangle for us, I'm going to draw my horizontal axis here, which represents my time in minutes. So this represents the number of minutes. And I need to draw the smallest number of this distribution. So my left boundary here is going to be represented by 2 minutes. And the right edge of my rectangle over here is going to be represented by the maximum number of minutes of 8. So I now have a rectangle drawn with a left edge of 2 and a right edge of 8. What I need to do next is I need to determine what is the size of this base. So to determine the length of my base, I'm going to look at these two numbers here, and I'm going to take 8 minus 2, which is equal to 6. So the base of my rectangle I've just drawn has a measurement of 6 units. We said here that my height has got to be 1 over the base. So if my base is 6, then the height we're looking at here is going to be 1 over 6. So that's how we're going to get the area of this rectangle I've drawn equal to 1. The next thing I want to do now that I've drawn the curve is answer the second question, which says, what is the probability that a randomly selected passenger has a waiting time greater than 5.25? So what is the probability that my variable x, which is time, is greater than 5.25 minutes? That's where we come back to our original graph we just drew. So 5.25 has to do with the minutes of wait time. And I'm going to just put on here a number in between 2 and 8 that represents 5.25 minutes. And I'm going to draw a brand new green rectangle here. And because I'm looking for probability of wait times greater than 5.25, I'm going to shade to the right of 5.25. So now you need to ask yourself, so now what I'm going to find in essence is the area of this new green rectangle. To find area, I have to know the base of this, or what's the width of my base, right? So from here to here, I'm going to take 8 minus 5.25, and I find out that that is 2.75. So the base of this new green triangle that I've drawn over here is 2.75. But did the height of this rectangle change? The height of this new rectangle I'm interested in is not the same height as the original rectangle we were working with. So when I calculate then the area of this green rectangle here, the area I've shaded in, I'm going to take the width of that rectangle, which is 2.75, multiply it by the height of that rectangle, which is 1/6, multiply those together on my calculator, and I end up with 0.458. So the probability that a randomly selected passenger has a wait time greater than 5.25 minutes is 0.458, or the percentage of wait times greater than 5.25 minutes is 46%. And that's how we're going to use a uniform distribution to calculate probabilities.